Hi guys, today is our last new video of this chapter. So next week is going to be all just reviewing and getting ready for our test. In today's final video, we are still solving equations. So there's going to be an equal sign. We're trying to find out what does x equal. But today we're going to put adding and subtracting in the denominator. So there's a possibility of factoring, definitely going to have lots of parentheses in our denominator. Let's go ahead and do that first example. Okay, so again, just like yesterday, we have an adding problem within our equation. And so on problems like these, we want to create a common denominator across the board, everything. So the entire left side, the entire right side, everything needs to have the same denominator. Now we need to remember that anytime that there's adding and subtracting in a problem, we got to throw parentheses around the adding and subtracting so that we remember this is one unit. We cannot change this. I cannot change a k plus 1 into anything else. It's got to always stay a k plus 1. So let's throw some parentheses around the denominators. I also changed one other thing, which is I changed the right-hand side to also be a fraction. So again, we do need to have every part of the problem be a fraction. So if something was a whole number, make it a fraction. All right, so now I can decide on my LCD, and my LCD for this problem is k plus 1 and k minus 2. You don't need to include the 1 from the whole number. So for my first fraction, I'm going to multiply that by k minus 2. For my middle fraction, I will multiply that by k plus 1. And unfortunately, on the right-hand side, I'm going to have to multiply that by both parentheses since it was not even a fraction to begin with. Now, just like our adding and subtracting problems that we were learning earlier, at this point in time, we want to keep our denominator in its factored form, but we don't want our numerators in their factored form. So I am going to distribute the k to the k minus 2, and over here I'll distribute the k to the k plus 1. And on the right-hand side, I'm going to have to do a little bit more than that. So on the right-hand side, I'm going to have to multiply together the k minus 2 and the k plus 1. You can do FOIL or the box. And then once you've multiplied those together, then you should distribute your 2. I would wait and distribute as the last step. So here again, I've distributed my numerators on the left side. On the right side, I multiplied out my k minus 2 and my k plus 1, and I will need to do one more step, which is distribute that too. But we got our common denominator across the board. Everything in the problem all has the same denominator. So we're ready to wave our magic wand and poof, no more fractions. Now don't forget, you can only do this if this problem has an equal sign in it. So if there's not an equal sign, you cannot make the denominators go away, and the problem will have to stay a fraction. All right, let's continue. So on the left-hand side, I'm going to combine like terms. So I will add together my k squares and my k's. And then on the right-hand side, I'm ready to distribute that too now. Lucky for us on this problem, when I go to move my k squares together, they're actually going to cancel out. So I'm going to minus the 2k squared on both sides. And so now there's no more k squares. That's a good thing. We like that because that means we don't have to factor for this problem. Well, let's finish this up really quickly. So I'm going to add the 2k to the other side, and that's it. K equals -4. Now, I talked a couple days ago about checking your restrictions so that you could see if there's any extraneous solutions. And so far in our videos, there haven't been any, but I'm pretty sure there's going to be one today. So let's check. Our restrictions on this problem are k cannot equal 2 and k cannot equal -1. I got those from the common denominator up here. And so we're in the clear. We're all good. K equals -4. That's not one of my restrictions. So we say that that is the final answer. All right, these problems are pretty tricky, so I have 2 more examples for us today, and then again, this is our last video for this chapter. Similar to the previous problem, I'm going to do a little bit of just writing things in a different way. So I'm not doing any math right now, but I need to throw some parentheses around that c minus 2, and that 2 in the middle that's a whole number, I need to make that into a fraction. So it's just rewriting the problem in a more user-friendly format. Okay, in this problem, my common denominator needs to include the parentheses, the c minus 2, and the c that's not in the parentheses. So those are completely different c's. So for your LCD, it is an outside c and then the c minus 2. That means that we'll need to multiply our first fraction by the outside c. This whole number, again, is going to need to be multiplied by the entire common denominator, the c and the c minus 2. And then the last fraction already has the outside c. It just needs the parentheses part, the c minus 2. Make sure that you're distributing your numerators, but not your denominators. Okay, so I'm going to do 2 times c. Right here, I can distribute a 2c. So 2c distributed to the c minus 2. And then right here, I have a negative 4, and I'm going to distribute that to the c minus 2. Okay, so again, parentheses in the denominator, good. Parentheses in the numerator, bad. No parentheses in the numerator, yes, parentheses in the denominator. And those denominators are going to disappear right now. All right. Let's combine like terms. And unfortunately, in this problem, the c squared is not going to go away. There's only the one c squared right here. And so we are going to have to set this equal to 0, and we are going to have to factor. So I'm going to subtract my 2c to the other side. I do notice that there's a GCF of 2. I can divide everything by 2. And then when I factor using Xbox, I get c minus 4 and c minus 1. And then that changes into a positive 4 and a positive 1. Okay, so I kind of skipped that step on the PowerPoint because I was running out of room, but you guys should know how to factor by now. We've been doing it all the way since like Thanksgiving, forever ago. So you guys should be really good at factoring, and if you're not, go back and practice. I gave you an optional Delta Math where you can practice the different types of factoring. I reposted the original factoring videos. You got to be able to factor for this chapter. All right, let's check for extraneous solutions. So in this problem, my restrictions from the outside c, it's c cannot equal 0. And then from the parentheses, c cannot equal 2. I didn't say it equaled 0 or 2, so we're good. All right, guys, last example. All right, let's see. On this problem, I am going to do 4 rewritings. So rewriting number 1, I can factor my first denominator. Z squared minus 9, that's a difference of squares. So I'm going to factor that. Rewriting numbers 2 and 3, I'm going to throw some parentheses around the other denominators. So z minus 3 and z plus 3. Rewriting number 4, I've got a subtraction sign. And I'm going to deal with that subtraction sign as soon as possible because I don't want to forget to deal with it later. So right now, I'm going to take the subtraction sign right here, and I'm going to distribute it to this numerator. So I'm going to change this to a plus sign and make that a negative z and a negative 3. Okay? So 4 things. Factor your first denominator. It's the only one that can factor. The other 2 can't factor, but you got to throw parentheses around it. And then I highly suggest that you distribute that negative sign. I would do it first so you don't forget to do it when you're in the process in the middle of the problem. Okay, my common denominator is z plus 3 and z minus 3, which the first fraction is already got that. So the first fraction is good. Middle fraction has a z minus 3, but it needs a z plus 3. And I will be FOIL or box to multiply those out. And then the next one, z plus 3, it's missing a z minus 3. And again, this needs to be FOILed or box method. You got to multiply the entire numerator with that entire parentheses that we just wrote in there. So make sure that you're multiplying that completely out using the box method or using FOIL. Both of those will get you 4 terms, and then 2 of them should be able to combine together. Okay, so if you're missing the middle term, that means you didn't multiply correctly. So make sure to go back and multiply it correctly. Remember, no parentheses in the numerator, yes parentheses in the denominator, and because this has an equal sign, I don't need that denominator anymore, so let's get rid of it. All right, at this point in time, I'm going to combine like terms. And, you know, I don't have the same z squared on both sides. That means that we are going to have to move everything to one side, and we're going to have to factor. In my opinion, I think the best move to make would be to move everything from the right side to the left side. And the reasoning behind that is if I move this z squared over, I'm going to add 5z squared. And so when I move it over to the left-hand side, it'll turn into a positive z squared. And factoring is so much easier when the z squared is positive. So when given the choice, move everything so that your z squared or x squared or whatever squared turns into a positive number. So I'm going to take everything from the right side and I'm going to move it to the left side. Remember, that means you have to do the opposite. So I'm going to add 5z squared. I'm going to minus 16z and I'm going to add 3. Okay, so do the opposite when you're moving it. And I get this. Now, this is Xbox, and this is one of those scenarios where you have to actually do the box for Xbox. You can't just do the X. The reason is that there's that 4 in front of the Z squared. So make sure that you're doing the X and the box. And whenever there's a number in front of your Z squared, that means you're definitely going to get at least one fraction answer. So here's what I got after I Xboxed. I set these equal to 0 and I solve. Before I put a box around this, let's check and see if there were any extraneous solutions. So if we think back to our LCD was z plus 3 and z minus 3, which means that z cannot equal 3 or negative 3. And in this scenario, finally, we came across one where we have one of our solutions is also a restriction. Now, restrictions will cancel out solutions. So we're going to go ahead and say that z cannot equal 3. It's an extraneous solution. And so the only answer to this problem is negative 1/4. Now, there are also scenarios where your only solution will be also a restriction. And so if your only solution is extraneous and you have no other solutions to circle, then you would say that there are no solutions to that problem. So that's also something that can happen. This concludes our final Chapter 8 video.